Good afternoon, sir.
Yes, good afternoon.
Sir, I'm Vedavathi.
Go ahead.
Sir, I'm
Yes.
Vedavathi. I'm doing the seminar on human body parts estimation and detection for physical sports movements. The main purpose of human body part detection is to estimate the size, orientation, or position of the human body parts. Estimation of various body parts of the human from an image is critical for several model-based systems and body tracking systems. Like we can't estimate the human body parts just by using the image processing. And so we are implementing a body part detection for post estimation. Like we'll estimate 5 key points, which is head and hands and legs. During foreground silhouette detection, the proposed method, we use segmentation techniques to obtain salient region areas and skin tone detection. Segmentation techniques like will detect the edges of the human body and will extract the main features of this, and we will also detect the skin tone. After successful extraction of body part, estimation is applied by using body part model. We'll use a body part model to estimate. So, and our main objective is to propose a human body part detection to estimate the size, orientation, and the position. And we use a project. Here we'll take two data sets, that is sports data set, which is KTH multi-view football data set and UCF sports data set. Here the main part is that we will extract the body parts, key body parts, and we'll use this in sports, detecting sports areas, sports pose detections, sportsman pose detections. And methodology we use is that we'll use pre-processing techniques. First, we'll pre-acquisition process, like salient region detection method is implemented. Like here, sir, pre-acquisition process here will detect the salient region detection, and in that foreground segmentation via skin tone detection, and then will in body part initialization will initialize the body parts, and here key point estimation, like what are the basic key points we need to extract, will extract here, sir. And based on the 5 basic key points, we'll extract 7 sub body points extraction, and then we'll track the body points, and then we'll recognize the body parts. Firstly, salient region detection method is implemented to detect the visibility, like what are visible parts. To detect those, we'll use salient region detection. Secondly, the method for foreground segmentation by skin tone detection on the basis of skin color will implement it. These detection methods are merged to get extraction of a person that is more accurate than any of the one method applied alone. So then we'll initialize the 5 basic body key points which are detected by using body parts model. In this experiment, we'll use 2 data sets. One is KTH multi-view football data set, another is UCF sports action data set. We'll check the efficiency of our method by estimating distance of detected points from ground truth. These are the parts: pre-acquisition, body parts initialization, and body part model. In body part model, we'll calculate the distance from the top area to the bottom area to examine the height and width of a person. First will normalize human head width of 1 by 8.5 times of the height. In the way we detect the head width by calculating the height by considering pixel. This is how these are the main 5 key points we'll detect. These are key points embedded in original image, and these are the lines connecting the points. Like these are the 7 key points, and here we represent that how a real image looks after detecting points. This is how real image looks after detecting the points. And our benefits are we can detect based on the pose and gesture. We can recognize them easily by using this model. And these are not only implemented in sports movement detection, we can implement this in other human activities also. And here we represent the method of detecting robust human via salient features and skin tone segmentation method. We proposed a novel body parts model scenario having basic body key points and body key sub key points mechanism. Our result will show significant improvements for conventional systems. In further, we have planned to incorporate the complex areas. Now, this will not work for the complex areas like wrist detection or such major parts. So we are implementing only on the major key points like hands and legs, head. But in further, we'll implement on wrist and all. And we have referred from the IEEE papers, which is of 2019 and 20. Thank you, sir.
How do you segment first here to what type of segmentation method that you use?
Yes, we will use edge detection. So, we can firstly will pre-process the image, like applying pre-processing image techniques like resizing, rescaling. Like we'll collect the data sets. From that, first one image will be there, sir. It may be of over pixel or less pixel. We will resize accordingly to which is for our data sets. We will take that and we'll apply the first pre-processing techniques and we'll detect the edge by using in segmentation. We'll be having one part called edge detection, sir. Using edge detection, we will identify the features. Like edge detection is that we'll extract the main key points like that. For example, in this image, what are the main sub key points we are concentrating on? We'll extract those features using edge detection.
See, in second image, B image, some lines are there. How you will get these lines?
Through that body part model algorithm itself. Like
What is that algorithm?
like
Name
for
of that algorithm?
like body parts model, sir. Based on like in that model, you will be using OpenCV only, sir. But in that model, we'll be having key features like where we can connect
Now,
those lines, sir.
my question is, how you will get those lines? See, the input is human body.
Yes,
That
sir.
human body is converted into an equivalent line diagram or line figure.
Yes, sir.
Hands, legs, and other parts. So these all the human body parts are written in terms of lines. How will get those lines and dots, which shows exactly the joints?
Yes, sir.
How do you get? Yes.
Yes, sir.
Go
Using
ahead.
image processing only we'll do, sir. First, we'll divide the images into right and left half. Then we do for each half points, we'll call BW label, sir, to label each point.
Now, what is
Then
that algorithm? I want the name of the algorithm which
algorithm.
draws the human figure into your lines.
Okay.
Have any idea on this or not?
Yeah, sir, I have a little idea on image processing, but I have not implemented that, sir.
You see, this seminar is not for implementation. It is just to know about the techniques.
But in image processing, we'll use line detection algorithm itself, sir.
Line detection algorithm.
Yes, sir. We'll be having one algorithm called line detection algorithm. Using that only, we will identify these and will connect these all lines, sir.
See, one algorithm is the thinning algorithm. See, hand is
Yes.
Represented as line using thinning algorithm.
Okay,
So
sir.
hand, see, some size will be there in hand. Okay.
Yes, sir.
So that hand is represented by a line using thinning algorithm. It thins that hand into a line.
Yes, sir.
So likewise, so many algorithms are there similar to thinning algorithm.
Yes.
Human body thinning algorithm, that is called as.
Okay, sir.
Just go through it, you will get some idea. If time permits, you implement that.
Yes, sir. Sure, sir.
Okay.
Okay, sir.
Get back to me after 3 days, and then you show me the implementation of thinning algorithm. Okay.
Okay, sir. Sure, sir.
Okay.
Thank you, sir.
Okay. Thank you.
Sir, can I end the meeting, sir?
Yes. Leave.